Okay, so welcome back to the channel, and in this video, as it says, I'm going to be adding probing to the 1997 Haas VF3. Now, I've got probing on my VF0E, which I added. It had probing at some point in its life when I got it, but when I got it, all that was still remained in the machine was a Renishaw PSU3, which is a 24 volt power supply unit, and the original Renishaw OMI, a white-faced OMI. There was no probe and there was no tool setter. So on that machine, I sourced a tool setter from eBay and a probe from somebody in the States, and then I paid an ex-Renishaw engineer who now freelances to come in and install it for me. That was about 3 years ago. Now, probing's a lot of money on machines, especially newer machines, and if you buy all the parts brand new from Renishaw or from Haas or from anybody else. But once you've used the machine with probing on it, I think you'd agree that to not have it is a real pain, and it does save a lot of time. So if it costs you £3,000 or £4,000 to get it, it's well worth the money if you can, and you will get that money back in time. You don't see it, you're not going to see it as an immediate gain, but it's so handy to have. And I wish I had a newer style machine with the next gen control, even a brand new machine with a new control, because with the probing there's so much more you can do. Now, if you use Fusion 360 like me, I don't have the extension. See, today I forgot to turn the compressor off. Let me go do that now. Apologies about that. Don't want that going off while we're talking. And also, while we're here, I'm gonna grab the actual probe because I forgot to bring that in front of me. Yes, so with the newer controls, there's so much more you can do. And if you run Fusion 360 like I do, they've actually got probing cycles in there which will call up your probing macros from the machine mid-part and do inspections. For example, you can come in, you can check a bore size. If it's not correct, Fusion will adjust the wear offset in the machine and remachine it until it is in spec, or it will error out to tell you the part's too late, it's out spec. So there's much more you can do on a newer control, but I've wanted to fit probing for quite a while. So over the last probably year and a half, maybe 2 years, I wasn't in a rush. I currently just use a Heimer 3D taster to set my work offsets and set my tools off of a 0 presetter that goes onto the table. And that works fine, it's just a little bit more long-winded. So the first thing I managed to pick up was a Renishaw OMP60. Now, if you guys have compared, and I will show you, I can talk off camera now because of the mic, which is nice. The OMP60 is a very big probe. Personally, I prefer another OMP40, or the current version is a 40-2. So this is an OMP60, this is an OMP40. You can see that is quite a size difference. Now, the OMP40 is from my Haas VF0E. Let's just put that safely out of the way. And the OMP60 is on the VF3. The reason I've got an OMP60 is because I got this from an auction. I bought the BT40 adapter brand new from Renishaw, and it's about £150. But the actual, because when I bought this, I think it was on a different adapter. It might have been on a 50 taper, something like that. But I bought some locally as well, some hydraulic holders and bits and pieces from an auction for £185. And one of them was this Renishaw probe. Now, you can't go and test it out or see it working, and obviously you can't even get it to turn on. You can get it to light up, but you can't test it unless it's in a machine with a receiver. So I didn't know whether it worked, but I wanted the hydraulic holders anyway. And when I picked it up and got it back, I fitted batteries to it. I changed the transmission method and I hooked it up to the VF0E and confirmed that it did in fact work and there was nothing wrong with it. So that cost me, along with 12 hydraulic holders, £185. So that was bargain of the century. Personally, I prefer a smaller probe, but for that money, I'm not going to argue. I don't really see why you'd want one this big when the OMP40 does the same job. But there you go. So that's the probe, £185. I had a couple of ruby tips anyway. It didn't come with a tip. I think it did come with a tip. It came with quite a long tip. So I had a couple of the shorter ones that I use more often. So there's that. Now, in the last month or two, recently, I've picked up the other two sections, and one of them is a brand new old stock TS27R Renishaw tool setter. Now, I think you can still get these ones from Renishaw for, I'm not sure how much they are, £1,300 at a guess. I'm sure it's there or thereabouts. And I managed to pick this up for £375, I think. Give or take 20 quid. I think it's £375. Brand new, unused, comes with the tools, the breakaway link. It comes with the round tool setting stem. It's got everything you need there, completely unused. So that was an absolute bargain. Even got the little spanner that comes with it. So that was a very good price. Separately, not separately, sorry, but in with that, it had the Renishaw M18 interface. Now they did do another one of these, which I'd also bought, an M18-4. Now, it seems like this is the one to use on a mill. From speaking to Renishaw, this one has got jog modes for X and Z, and they said it's more often used in lathe setups. So it will light up and tell you when you're jogging axes or something like that. So they said this is not really the one you want to use this one. So we've got one of these. This was brand new, old stock again, off eBay for about £40. So they do pop up quite often, so they're ready and available. Tool setters, again, if you keep an eye out, you can even buy a used one. I just didn't want to buy everything that seems to be on eBay when you're in the UK looking, seems to be from China. Now, I don't know if they're just used because they've got so many CNC machines out there, or whether they are copies. So I waited until I got one brand new. And it come with a box. We've got the instructions and all that. And then a couple of weeks after that, this was on eBay, and this is a Renishaw OMI2. Now this is the newer version, the current version of the OMI. Again, brand spanking new, unused. The only thing that was missing from the box was this conduit kit, which is a seal-tight kit. And if you don't have that, you're going to get coolant up inside the OMI and you're going to ruin it. So I've had to wait a few days to get that on order. So this new is £1,280 plus VAT. I paid £505 including delivery. Again, new old stock off of eBay from somebody in the UK. And I had to go to Renishaw and buy the 1 metre conduit kit, which was about £50 including the VAT. So again, we got brand spanking new, and that is, it comes with the toolkit, the little fuse link, the little cable fittings that go on the end. It's got everything you need on there. And then I also have, which is fitted to the machine, I won't get up and show you, it's just the bracket that this mounts on, which I bought as an aftermarket off eBay. I could have made it myself, but it was like £30. So I bought that a long time ago as well. So we've got everything we need to do the, to run workpiece probing and tool probing on the machine. Now, I'm quite lucky in the sense that the VF0E had probing. So I was able to go on to my machine that was wired up by the ex-Renishaw tech and just write down everything, which one did I use? Write down everything on that machine. So I printed out the configuration from the OMI and I've made myself a little sketch because when you're using a workpiece tool setter, which has to use the optical, and a wired tool setter, then you need to switch through which one's being used by the machine control, the M code, via a relay. And Renishaw use, or in all their books it says about I don't know how you pronounce it, it's a Wieland relay. So you can see on the picture, that's what they look like. They're just a thin DIN rail mount style relay, and I've actually got it here rather than show you a picture. So that has got 24 volt input to activate the relay. Then you've got a normally closed and a normally open, and obviously your common. So that's what we're going to use to do the switching. Now, in an ideal world, I'd really love to have the Renishaw OTS optical tool setter, then you haven't got to worry about the cable being dragged around by the table. Because on the VF3, I've had the cable split a couple of times now, and I've shortened it, and it would just be so much nicer not to have any cable. But the cheapest I've seen one of them going for was about £2,000. So compared to the £350 that I paid for this, it's a lot of money. And the other thing, if you go to the to use an optical tool setter rather than a wired one, you get what's called, you can, for the same price, you get an OMI 2T, which means it can handle two signals, one being from the optical tool setter and one being from the optical workpiece probe, the OMP. So you don't need the wiring. I don't think you need one of these boards. I think it's all done through here. So in that sense, it's a much easier install, but again, that was slightly out of my budget. I'd like to change to that in the future, so we'll see what happens. Yeah, so I've took some info off of the other machine to get me started. The one difference from this probe, the OMI2, not the probe, sorry, the optical receiver, compared to the old one, the old white face, which I'll show you now, so the old white face, which is there, could do with a new glass panel really, but they transmit with, it says, legacy. Let me have a look at the, just put you back there. So what you have here is your probing sheet for trigger logic. So this one is specifically for the OMP60, but you can download them, and I think it's the same for all. So it shows you the sequence of lights. When you remove the batteries and put them back in, then it goes through a sequence to tell you what the settings are on the probe. And then if you download it, there's another sequence which shows you how to change those settings to suit your setup. So on my older VF0E with the OMI, it's a legacy optical transmission method. On the newer OMI2, the yellow face, it's a modulated optical transmission method. So that had to be changed in the probe. It can be a little bit fiddly just to get the hang of how you get into the settings and how you change each one, but once that's done, it stays there. Even if the battery goes flat, it remembers that. But if you put the batteries in, you can run through the sequence and it does a certain flash in a certain colour to tell you what it's set to. So that's easy enough to do. It's sort of a 5–10 minute job to get your head around it. So I've got everything I need. I've got a rough idea of how it needs to be wired. Now, I'll show you on the machine. I'll just be careful because the machine is turned on. So, these boards up here, maybe I'll zoom in a bit. These up here are your spare N codes. So currently, M21, you have a normally closed, a common and a normally open. Then again M22, normally closed, common, normally open. Now M23 and M24 are just a common and a normally open. On the newer machines, I think they're all normally closed and normally open. They've got the option for both. So on this one, M21 is already used by your optional M function, which is this little one here. If you look on the machine, it's that connector there. Now 9 times out of 10, when I've used that in the past, That's been for, say, the old Haas 5C servo indexer. And there's probably other things out there that use it as well, but that's what I used it for. So we're going to be using M22, that's the common one for the probing. Now on newer machines, on the input-output board, you'll be looking for P22, I think it is, which will be a skip signal. Now this is an older machine, so my VF0E uses P22, which is the skip signal. On this machine, P22 is something else. The older machines actually use P47. And if I can zoom in there, you'll see, I'm trying to get my hand around the camera, it says P47, get my finger out of the way because it's focusing, and it says skip next to it. So that is your skip signal. So on that you're going to use pin 1, which is the top pin, and pin 2. Now it doesn't matter about the polarity of them, I don't think, but I'm going to double check that and go into it at a later date in the video. I'll try and do this in one part. It might be a bit long and a bit tedious because there's a lot to go through, but I'll try and do it in one, and I'll skip the bits that are quite simple. So because this hasn't got the Renishaw PSU3 power supply, you need a separate power source. Now I have wondered about taking it straight off of the board because we need 24 volt I think it's between 12 and 30 volt power supply. Now you've got some power supply spares here, but I'm not sure about coming straight off this board. So I've actually gone and bought, I haven't even opened it yet. I'll try and open this. Actually, let's put the camera back down because there's no point trying to faff around and probably drop something. So in the UK, I've just bought this off Amazon, and this is a 110 to 220 volt input, and it's a 24 volt DC output. So it's an AC input and then a DC 24 volt output, and that's what I'm going to use for the power supply to the probe. And then I know it's going to be separated from the input output board because for whatever reason, I'm not an electronics guru, I just follow instructions. I don't know if any sort of if there's nothing between it or it's not fused properly or something like that. The last thing I want is damage to the I/O board. So I'm going to use one of these, and I'm going to power it off of one of the main sources of incoming supply from the machine. Now, Renishaw supplied me some example wiring. Now they won't supply machine specific wiring that can be followed step by step, because you have to have one of their engineers come in and assess the machine and do the install for you, but they can supply, they do have some example wiring diagrams that, as stated, they're not to be copied because they are not machine specific. So everything is down to you guys. You cannot follow exactly what I do on this machine. You cannot follow anything you see exactly on any of the example bits of paper wiring that you may see in this video. You need to make sure everything is specific to your machine and your setup. So if there's any errors or any damage is caused, it's going to be at your own risk. So please do check what you're wiring, how you're wiring it, and that everything is right so you don't do any damage to either the machine or the parts. So on one of the examples that I've got here, let me try and put the camera down here a bit. You can see there's some notes here, and on one of them it says there, older machines have used P47 and not P22 for the probing input, which is your skip signal. You cannot use the low battery buzzer, which is the output of the OMI, as this only gives 12 volt. And then you've got at the top there, sorry, 94 and 95 or 91U and 92V can be used for the power supply unit input voltage 110 AC. Now, as said, this runs 110 to 220 AC. Now, what they mean by 91, 92 and 94, 95 is on your power supply board here. I'll just step in one. Here, you've got 94, 95, and down here you have got 91U, 92V. So they're saying you can come off either of these on the first two wires, and that will give you your 110 input for your power supply. So that's what I'm going to do. I'm going to come off of there and run some power supply off that. I'll check it first. I'll probe it first, make sure the power supply is correct and we're getting the right voltage, and then that's what I'm going to do. I'm going to run it like that. So I'm going to mount a couple of bits in the machine first. I'm going to get the OMI mounted. I'm going to get the TS27R mounted to the table. I have got myself some sections of DIN rail off of Amazon, literally about £4. You get them in a pack of 4, you only need 1. I've got the Wieland or Wyland relay. I'll show that there. There is a part number on it. I'll probably put the part numbers and stuff in the description. Anyway, off of Amazon, a multi-pack of fuses, because some of the fuses that it says on this diagram, now I've not double checked to see if it's going to apply to this install, but you need like a 0.1 or 100 milliamp fuse on one part of it according to one of these diagrams, but I'm not sure if that's how this is going to be wired. But just in case, about £9 of multi-box of fuses, and if I do end up using one of those fuse setups, some inline fuse holders. Now these come as a multi-pack. That actually comes the kit for £9, so you get about 10 holders and all the fuses. I wanted a bit of earth cable, and randomly I didn't have any here, so I bought a couple of meters, I think it's 5 meters of earth, which I'll need for the wiring. And then I think, just going through it, apologies for hiding away off the camera, and apologies for the noises, because I've got a cold, it seems. Okay, so the other thing I've got here is wiring connectors. So these are DIN rail mounted, you see them, and these are the pop-up style. So when you're splicing wires together, you're not going to be using bullet connectors or gaffer tape or soldering wires. When I want to join stuff, we'll be putting them in these connectors that are just like a snap lock. That's what the engineer or a similar version they used on the VF3, and there's no problems whatsoever. And again, these can just be rail mounted on here, and then the same as the relay, that can also be rail mounted on there, so everything will be nice and tidy. So yes, these, I think a pack of 10 was around £3 or £4, again off of Amazon, so they're easily sourced. The relay was £15. DIN rail, as I said, was about £5, maybe £4, £3 for that, £10 for that. Power supply was £15 from Amazon. And the last thing, which you guys probably won't have, be good if you did, but the thing that you won't have that I've got is, excuse me, on the I/O board you've got different type connectors. Now, where I broke up, if you see one of my previous videos, I broke up an old Haas VF3 and I scrapped it, stripped it for all the parts. Well, I got all the wiring off it. So I've got plenty of cables, and I managed to find one, which I can't remember what it even says this one was for. An E-stop, but it's got the correct connector for the I/O board, P47, which means I haven't got to try and source one of these and source the pins for it, because you don't want to be attempting to solder wires directly to the board. I don't know what connector this is, so I'm afraid I can't tell you, but you can probably research that online. So I'm lucky I can use this, I can cut it wherever I need it, and then I can put the other end of the cables straight into my connector blocks. So that's going to save me a lot of messing around. If any of you guys know what connector this is, put it in the comments, because that'll be helpful for other people. And then for the other wiring, any other sort of wire I'm using on this, it's probably a bit heavy duty, but it's just going to be automotive copper strand cable, you know, nothing fancy, nice and simple. So that is everything I think I'm going to use on the actual component side of it. Now, as far as the machine side of it goes, if you're gonna use the try and straighten the camera there. If you're going to use the Renishaw setup, you're going to need macros enabled on your machine. I've read a couple of people done it writing their own kind of code. On my other machine, again, I'm lucky because macros and all the Renishaw macros, I have them on the computer, the Renishaw Inspection Plus, I believe it is, and I have them installed on that machine. I've got macros turned on. I turned macros on this machine, and I basically took the programs off the VF3 and plonked them straight into the VF3. So I've got exactly the same setup. So you'll need macros and you'll need to get the Renishaw Inspection Plus. I've got a copy of it on here. If anyone needs it, just ping me an email and I can send it over to you. But obviously, yeah, to use that, you need macros enabled on the machine. Now, once it's there, there's loads of probing cycles in it for touching off a back left corner, a back right corner, a boss, a bore with an island. There's all different probing cycles. I tend to use just the generic ones, and I tend to just type them myself in MDI because that's the way I started to do it, even though I've got the programs and I found it quicker. So for example, on the older setups, if you're probing a single surface, like you're going to probe the Z of a surface, you'll use G65, P9023, Z-10, and then you put S54 or 55 or 56 to correlate to a G offset. So S54 is G54. If you're going to probe across the Y axis of a part, you put G65, P9023, D, say 50 for a 50mm diameter part. If you're in a pocket, you don't need to put a Z, but if you're coming over the top of a bit of stock, you need to go D50, Z-10, Y1 to tell it you're in the Y axis, and then S54, S55. But I'll show you that when we get round to it. So yes, I think that's it for the minute. I'm going to get all the hardware installed and put in place, and then I'll bring you back and show you where we're at. So bear with me and I'll see you in a second. Okay, so we've got the probe wiring installed into the machine. Now it's a few days later because I had some other stuff to do, and it isn't a 5-minute job, to be fair, not for me because I'm not that good at electronics. I'll take you over to the machine and I'm going to show you what we've done. So in here now, we've got our power supply wired in. We've got our TS27R tool setter interface, and then we've just got our connector blocks and our 24-volt DC relay, and all this is mounted on a piece of DIN rail. Now, the power supply, as per the Renishaw example wiring, this is switched as, this can be 220-volt or 110. I'm running it at 110, and there's a switch in here that you have to swap over and make sure it's correct before you turn it on. So we're taking 110 and we're coming off of terminal 94 and 95 on the power supply board here, and we're running an earth. We've got a couple of earths there running from the main block in the machine. Now, I've wired it up as per my other machine. Some things are slightly different from the examples, and the examples given were OMI, not OMI2, and there's some colour differences in the cables. But I've wired it up exactly as per my other machine, which was done by the ex-Renishaw tech, and that's worked fine since that was put in, no issues, so I've done it the same. Now, the general gist, because I can't go into it too much because I don't know the ins and outs of everything, but the general gist of what's happening: you've got 24-volt power supply coming in, which gives power to the the OMI and the TS27R tool setter. Now this bit is purely to do with the TS27R. Now you've got the blue wire and the red wire here and the twisted one next to it, which isn't as neat, but that's just a screen. Then you've got an earth, then you've got a power, you've got the negative or positive and negative inputs from the power supply. On this side, you've got two output signals. Now, you can set the whole setup to be normally closed or normally open. On a TS27R, you will normally run it normally closed. So, forgetting the probing side for a minute, with the tool setter, whenever the tool touches the stylus, it basically gives an output to these connectors B6 and B7, which would be connected to your skip signal, which on newer machines is P22, but on the older machines is P47. And if you can see there, it says skip next to it. And when the machine control senses a skip signal, obviously it knows it's touched off, and then the macros tell it to do what it's going to do, you know, about changing heights and offsets and all that sort of stuff. Now, when you're running both together, what you need to do is you need to run one of your optional relays up here. So on mine, M21, or pretty much on all machines, is already set and it's used for this little connector here, which is your optional M function. I've only ever used that on my other machine when I had a Haas 5C indexer. Other than that, you're probably not going to use it for much unless you've made up something yourself that uses that function. But you don't need it for your fourth axis or anything like that. But it's normally pre-wired into the machine as they come. So we're using the next one along, which is M22. Now your optional M codes don't get activated by an M code. They don't get activated by M20s. They go randomly enough. M22 to turn it on will be M52, and to turn it off will be M62. Not sure why the numbers jump up. So if you had M24, it would be M54 to turn it on, M54 to turn that relay off. Again, no idea why it's like that, but it is. So we're using M22. Now, you've got a normally closed, a normally open, and a common. We're using the normally closed and the common. And basically what's happening is, when you call up a Renishaw macro, depending on which macro and tool setting function you're calling up, whether it's the workpiece probe or whether it's the tool probe, it will activate the M code, which will then activate either power to this relay or not activate power to this relay, which means it will be probing from this. So I think this is wired as the what would you call it, the main the primary option, and then this one is the secondary. So when the tool setter probe is called up, that activates your M22, which will be M52, and that puts power to the relay, which switches it, because you've got outputs here, switches it so that it switches to take the signal from the tool probe. That's the general gist of it. I know that's a pretty poor explanation, but that's about as good as my skills go. This video is more to just show you what's required and how easy or hard it is to install. Now, I am happy to give you guys a diagram. I can't show you it right now because I haven't drawn it up. Give you guys a diagram, and I'll put it at the end of the video, of how I've wired my machine. Now, please be careful. I don't take any responsibility if you copy the exact wiring from my setup. It's an example to show you what I've done. Anything you do is at your own risk, of course. But I'll show you how it's wired in this machine. So again, you need your optional relay, which I'm pretty sure most machines have got, maybe not the early DC machines. I've never owned one of them, so I'm not too sure. But this is a 1997, my other one's a 2000, and they've both got it. You'll have skip signal, which will be P22 on a newer machine, like my other one, only a couple of years difference, but my other one is P22, this one is P47. But it will say skip next to it. You need yourself, obviously I've been through this earlier, your power supply, your M18 interface, because you might end up buying a T27R like I did. They don't automatically come with this. You could buy it on its own, you could buy it as a kit with this, or there's some other interfaces, but this is what I'm using. Obviously, your connector blocks, your bits and pieces, and we showed you how we wired it up there. Now, one thing I would note is that the cables don't need to be this thick. This is 2.5mm earth, and it's too big for these blocks ideally. I had to cut some strands back to get it in there and join it. Now, there's a fair bit of the OMI probe you don't use, which is like error signals, probe status B, and some other bits and pieces. You don't need them. So out of the probe, what are we using? 1, 2, 3, 4, 6 wires and an earth. Now the earth again is the screen of the cable, and because I've stripped this all back, the nice solder bit that comes supplied with it, you end up with like a big frayed cable like that again. You have to twist up, and I've connected that to the earth and then taped it up for the minute. I need to do a neater job, and I think I will order like 1mm earth cable, and even I think this is 1.5, but we'll order smaller stuff because it's a bit big. I won't go into exactly how it's wired to tell you right now, because it's going to get confusing, because I'm not too sure myself without sitting down and re-looking at it. But basically, turquoise is a probe, your probe status, then you've got cable from your skip signals, you've got your powers, you know, pretty basic setup really, but it works. Everything seems good. Again, apologies for the poor explanation. I'd like to know more about wiring and all that sort of stuff, but there's only so much you can learn about so many things. Okay, so we've got the OMP60 in the machine. We've got the OMI mounted on there. We've got the TS27R mounted on the table. Now you need to clock this in the X and Y axis to make sure that stylus is flat, not on the tilt. And they say to do that within about 5 microns, which I've done. When you're setting all this up, you don't need anything specific to that other than clock it up. But when you're doing the probe, you're going to need yourself a ring gauge, like a known size diameter ring gauge. Now, with the macros, let's just undo the emergency stop. I was lucky enough that I had the Renishaw Inspection Plus, all the macros and bits and bobs from that machine. I turned the macros option on this machine, and then I've just basically copied the programs out of that one and I've put them into this one. Now, if you go into your settings, if you've got these programs, and you turn your programs trace off, it will show you every single 9000 series program you've got. And with the Renishaw stuff, there's a lot of them. So I've got spindle warm up automatically, which I keep in there. Now you've got the main ones you're going to use when you've got the TS27R, the only ones, is the auto tool set length and diameter. Diameter's very handy if you're using a tool that's been reground, or you really want to get in there and find it accurate, because some tools aren't as good as they say, depending on the quality of the tool, or again, it's just worn. Then you can touch off, look at what it tells you the diameter is in here, and then you can put that into your software to say, rather than just saying it's a 12mm and finding out it's 11.92 or 11.8 or something like that, you can exactly go back and put the exact input of the diameter of the tool in. But mainly, tool set length is the one you use. But what happens when you do a diameter, which is good, obviously the tip of the probe is only 12.7mm. So if you're touching off with a face mill, say this is only a 50mm face mill, it will try and come down dead center, which wouldn't happen because you've got a gap there, you'd crash it, you'd cause damage. So when you're using a bigger tool, I think it's set in the program, I think if it's bigger than 16mm, yeah, if it's bigger than 16mm, you have to use the length and diameter. Then what happens is, when it comes down to do the measurement, it will automatically step over half the diameter. So the tool will come down on center and then it will shoot across, say on this tool, for example, 25mm, so that the tip is going to touch the center of the probe. And then when the tools are touching off that way, they spin backwards so that the tip doesn't clash and chip on the stylus, which is good. So that's what you'll use for the 27R. Now all these ones are for the OMP60, so they're workpiece programs. You've got right left corner, rear left corner, front left corner, probe in a bore, boss with islands, single surface pockets, cubes. There's lots of them, but you come down here and you've got TS27R calibration and spindle probe calibration. You've got safe tool change, which is one I had. And there's ones that I've never even delved into. So you've got Renishaw start setup, X dimensions, Y, ACT offset settings. You know, there's all this sort of stuff here, Renishaw print. I haven't got into any of that. I pretty much use, because you've got a full calibration here for the probe, and I've also got one here, spindle probe calibration. So I don't really know the difference, I'll be honest with you. What I have found in the probes, which is pretty much good enough for me anyway, is that when I'm probing something, the probe straight out the box is normally accurate within about half a thou, 0.01, maybe just under a thou, 0.02 millimeters, which for most of my automotive stuff, almost everything, that's good enough for a location. If you need it more accurate, I'm not sure how you go and tweak it to make it more accurate, because I've found that on the calibration cycle, it will still be out by about 0.1. Now, it's not the machine, because I know when the Renishaw tech did it on here, we were getting it within about 2 microns. And I remember when I went back previously, shortly after he'd done it, and I broke a tip and I rerun the cycle, he told me how to redo it and tweak it so you can sort of, right, okay, we're half a thou out, 0.012 millimeters. Now you need to reclock it and do this and do it until you get it where you want it. So you can get it very, very accurate. I just can't remember how you go tweak it. So I might speak to him and see what they say. So the first thing you need to do is you need to give a rough gauge length of what your probe is and put it in your setup, because if you don't, obviously it doesn't know where the probe is in general. Now, it doesn't really matter which you do first, what you set up first. I've got the probe in here and I've got the ring gauge there, so I'm going to do that. So if you go into your offsets, I always use tool 20 for probe, 162,809. Now, when I'm rough measuring the tool, I literally use a steel rule. I put it up there under the spindle and I look down here and I am at, with my thumb, 161, 162. That's close enough. As long as you're within, say, 10 millimeters, it will sort that out. So obviously I've got it in there already, which is accurate. So for the calibration of this, now I've done this calibration, the basic calibration, quite a few times, so I know where I'm at. You've got your ring gauge set. In the macros, you need to tell it. So I'm at 64, sorry about the picture, 64000. Now, I'm going into the spindle probe calibration. If I go into edits, it's easy to see it all. We've just got our program there. Just spindle probe calibration, but if I go into the other one actually, or maybe it's the other one I use, it's this one because it's got instructions on it. Sounds stupid, I don't know the difference between the two. Okay, so you've got full calibration of OMP40. Now I don't think the fact it says OMP40 matters, because the probe itself is irrelevant, it's only the tip and the stylus and they're the same size. Clock a ring gauge and set G56XY. So basically, use your normal style indicator, secure your ring gauge to the table. You don't really want to use it in a vise because you might crush it out around ever so slightly, so you want to clamp it straight down to the bed or onto something is probably the best way. So you want to set G56, obviously that could say G54. You then only have to change it when you come down further into the program. Set G56Z to the top of the ring gauge, so basically set it level with here. And it can only be rough because it's going to reprobe it. And then set the approximate Z offset in H20, which is your height offset, which I've done. And then position the probe 10 mil above the gauge. So we're roughly 10 mil, hasn't got to be exact. And then in these programs, the first move here is X40, because what it's going to do is going to probe the top of the ring gauge to know where it's at. Now, the X40 obviously might be X100 or X15 depending on the size of the ring gauge you're using on the calibration. So there is certain things that you'll have to change, like X40, to make sure it comes across halfway and lands on the face of the ring gauge. If not, you'll be over here or you won't touch it. And then you've also got further down D64. When you're calibrating the stylus, this measurement here, this D measurement, diameter, is what your ring gauge is. So mine is exactly 64 millimeters. So you need to make sure that says the same for yours. So now if we go into the actual program, so it backs off, not sure why. Then it's basically touching off our Z, which is just done. Comes back into the ring gauge, and now it's going to measure off the bore. Now, it measures off the bore in your normal X and Y, and then it goes through and starts picking off different points at different angles, and I think that's to do with the vector stylus calibration, something like that. Now, the other thing that can affect the calibration is I've bought a few of these stylus tips on eBay. I think from Renishaw they're about £50 each, and I've bought a few on eBay for like £20 each. So some of the error that you get, I've not mic'd the little ruby on top of the tip, but if you're going to buy a cheaper tip, then obviously they may not be as accurate, so that's another consideration to take into. And also you've got the temperature where you are for the ring gauge, because most of the ring gauges in the UK, Celsius, will say temperature at 20 degrees. So everything can make that a little bit out, you know. I don't think you can input for temperature change on the setup. You just probably need to make sure that your ring gauge is calibrated or is the exact size that it says. So you see now it's going through different angles rather than just in your standard XY. Apologies about the noise. Can't help with the fan on these gearbox machines, it's quite loud. Okay, so that is the OMP60 Pro calibration completed. Now you won't see any difference, but what you can do now is come back straight in. Just come straight into the bore there, and I'm going to do a manual G65 P9023 D64 S, let's say 57, so G57. So anyway, now this is going to probe that. Cycle start. And then if we go to current commands and macros, macro 138 is going to tell us the size that it's just probed. Now we'll see how far out it is. Like I say, there is a way, once it's done its probe calibration, you can tweak it or whatever to get it more accurate, because I know it can be like in the microns. It should be in the microns. And I know it's not wear and slop on the machine, because the machine's actually really good. So I'll have to look into how you recalibrate it, but this gets you going. This gets you started. Okay, so it's telling us it's probed it at 63.987, and then down here macro 143 tells you your error. So we are under what we told it by 0.013 millimeters or 13 microns. So okay, for most of the stuff I do, I wouldn't even bother with that. But it's nice, I'd like to get it better, and I'd like to refresh myself on how I tweak that down. I'd like to know where my errors are for that 0.013 millimeters. But that's your tool probe calibration done. Obviously you need that program to do it. There's not much for you to do, you just got to have the program in the machine. Now you need to have macros enabled on your machine, if not obviously none of this is going to work. So let's get rid of the probe. And now for the tool setup, because it's all built into the cycles, when you do your G65, which is what you call the macro, and then your P9023 calls a specific program, then now when I go into the tool setup, I'll use the programs in the memory, and as mentioned earlier, when one of these is called up, that's what's going to change that optional M code relay to tell it what probe it's about to use. So obviously we use that. This probe is now timed out because it's on a 60-second or 30-second timeout, so all the lights are red. So it's gone back to this probe. So it won't do anything when you touch it, but it's connected now. You can hear it beeping, and then that will cut off after a certain time as well. So if I want to now measure my actual probe tool, again, you have to have a measurement in there. If you forget to put a measurement in here and you set that to 0 and this comes over, you're going to crash the machine because it's going to try and put the tool into the table. So you always have to have a height offset in here within 10 millimeters. So mine was already preset, but I'd go into, I'm just going to do the length, auto tool set length. So I'd click on that. Then you want to edit, and you'd come down to the T number, like here, and you type in T20, T6, T4, whatever you're doing, alter, and now, let's get off the current commands page. Now you're ready to go. Now what you're going to do, I tell you what, actually I've skipped a step, forget that. I've got to show you how to calibrate this first. So let's go, the tool's in the machine. I'm forgetting where I'm at, trying to get it done. So I'm going to swap tools now. Now you need a known length tool for this. Now I'm not going to go into that because that can be a 10, 15, 20 minute video on its own about how to get your known length of the tool. You can buy known length gauge tools which give you an exact micron measurement from the gauge line to the tip of the tool. I've just used a broken 20mm carbide end mill and used the tail of it in a side block. Not ideal, but this doesn't care much about the diameter, mainly cares about the length. Now it's very faded, my arm, but you can see 112.976. Now that you need to know, and you want to put that in the corresponding tool offset. So my one is tool 10, 112.976. Now it doesn't matter what tool you put that in, it's irrelevant. And the TS27R calibration is a lot easier, to be fair. What you need to do is you need to jog above it and make sure you're roughly in line in X and Y. The more accurate, the better. If you want to clock around the stylus, which is what I will do in a minute, but I can't do all that with one hand and the camera because I haven't got you set up on a tripod. You want to come down and jog 10mm above the stylus. Make sure your stylus has been clocked first in X and Y with your indicator to make sure it's level, and you adjust the level with these 2 screws on top, does your tilt, and the front and back does your tilt that way. Then again in our programs you see that I've got one that says TS27R calibration. Come into that and you see it shows you all these different macro variables. Now I can't tell you what all of them are, but I can tell you that ones like this 560, -2, -2, -2, is to do with where the tool setter is positioned on the table, so it knows which way to go backwards and forwards and touch off when it's doing a diameter, and I said it moves halfway across. If it tried to move this way, it would error out because our limit of travel in the X is about here. It's not off the table. On the Y it's off the table, but it's not on the X. So you have to check in the manual, and it does tell you which way to go. So that's what that relates to. but I can't remember off the top of my head. But I do remember that my tool setter on this machine used to be over here, facing the other way, so the diameter measurement, when it went to do the diameter, it had to go that way to come down and come half the tool off. This one, I remember I changed it to a -2 because I moved it to that side, which means it's got to shift halfway that way. So that's what they relate to. This K measurement is your known tool length. And I'm trying to go through this quickly. You've got S20, which is your tool diameter, and 12.7 is your stylus diameter. So it hasn't got much info in there, you don't think, but obviously that's what it tells. And basically when it's doing this probing cycle, it's telling it where the stylus is exactly in relation to the machine. So, and it will save that memory in one of those macros, so it knows where it is every time you run the cycle. So let's go into this now. So you can see there, TS27R calibration, jog to 10 mil above the stylus. 10 mil above the stylus, press cycle start. Touches off. Backs off. Basically does 3 touch-offs. So it does a first quick one and a second one, which is normally all you get in a probing cycle. But during the calibration, it does a third one. And it's feeding ridiculously slow. You can see it counting up there. And eventually, after a while, it will touch off, but it's a bit tedious because it does take quite a long time. Once it's done the touch off, it's then going to move to the front or back of the stylus. There you go, to the front, what I'd call the front. It's actually the side. And it's going to touch off on both sides. And I think it does that twice to work out where the position is in Y. Now, the position for X, it's assuming that you started dead center. It doesn't try and touch off in X because it could probably do a half measurement from one side, but it doesn't. So the X alignment is wherever you've left it when you started. That's why I said it would be nice to pocket up, but I won't get into that on the camera because this video is already pretty long. So there is a couple of bits in this one. It doesn't show an optional stop or an M0, but it does stop until you press cycle start again. I'm not sure why. That's just how the programs come. Maybe they've been amended like that. But you don't have to do anything in between other than press cycle start once more. So that's the second time it's done that. And that is it. The TS27R calibration is done. So going back to where we were earlier, if I now say, right, I want to set my, let's forget the probe because we've had that one out. Let's say tool 2. So if I sit there and go tool length, I'll go edit. Currently it's at T20 because I was going to calibrate the probe. If I go T2, alter, home, back to there. Now remember, in my offset, I must have something within 10 millimeters of the height of the tool, measured with the steel rule like I showed before. So now if I press cycle start, it will go select tool 2. And it should stop around about 50 millimeters above the stylus. Then it will feed down slowly to 10 mil or 8 mil, which these are some of them macro numbers that I just showed you a minute ago. Now it will touch off, then it will back off, and then it will touch off again. And we may see number 2 there change, yeah. So it changed by 0.01. And there we go. That is everything set up and working. Sorry, it's been a little bit of a long, boring video. Let's try and end some noise there. I have got copies, or I've got a copy on my computer that came with this when I had the guy install it, of the Renishaw Inspection Plus. Now, if anyone needs that, then give me a shout. We sure can sort something out to help you out with that. But again, beware, them files were given to me before they've been put into a machine, in the sense of they're probably just your basic generic, so I do not know the ins and outs of what's preset in those macros. So you really need to find, I think I've got the manual in there as well, so I might have the actual macro 9000 series programs and the manual. But if you ask for them, if I send them to you, if you get them from anywhere else, if you know, I don't know if they're just generic online and you can source them, you need to make sure what's in there, you know what's set, because you could crash your spindle probe, your tools into your brand new TS27R. You know, you could do a lot of damage if you're not careful. So that is just one thing to bear in mind. I don't think there's anything else really to go over. I don't really know if this has been the kind of enough information for you guys to see what's what, but you can put probing on an old Haas 1997 and a 2000. If the prices are good and you buy stuff secondhand off eBay like me, new, old stock, used, doesn't matter, it still works and it costs you a lot less than buying it brand spanking new. Obviously, if you want to do that, that's all well and good. But having probing on the machines is a massive, massive help. And once you've had it, you will not want to be without it. Hence why I've waited the last year and a half or however long it's took to collect the pieces to put it on this machine, because it literally, even on old slow machines like this, it just changes the game and helps you so much. So I will add a diagram of how this is wired. Be careful copying it, copy it at your own risk. And I'll add the prices of what I paid second hand for the bits and pieces I needed to install this on the machine. So yeah, thanks for watching. Please like and subscribe if you like the content, and we'll see you again soon on the next one.